laws of indices, and this is for O-level code 4024. Our first law says, in general form, if a power m times a power n, so what we do with this, we will see the bases are same, which are a, and they are multiplying with each other, so power must be added. So we will write it like this, a power m plus n. Let me give you example. For example, if I write 2 power 3 times 2 power 4, so bases are 2 and they are multiplying with each other, so power must be added. So I will write 2 power 3 plus 4, which gives us 2 power 7. Second law, in general form, if I write a power m times b power m, notice one thing, that the bases are different now. One is a, another is b, and they are multiplying, but powers are same. So we will multiply the base a times b, and we will take common, the power common, and we will write m one time. So further you can also write ab whole power m. Let me give you example on this. Suppose if I have 2 power 3 times 3 power 3. So bases are different and power are same, and bases are multiplying with each other, so I will multiply 2 times 3 and I will take 3 once as a power. So this will give me 3 times 2 is 6 whole power 3. Number 3. If a power m divide a power n, so bases are same and they are dividing by each other, so I will write a power m minus n. For example, if 2 power 4 divide 2 power 2, so I will note that bases are same but they are dividing by each other, so power must be subtracted. So I will write 2 power 4 minus 2, which gives me 2 power 2. Number 4. If a power m divide b power m, so here we notice that the bases are different and they are dividing by each other, so I will divide the bases like this and I will take power as common value. For example, if I have 8 power 2 divide 2 power 2, so bases are different and they are dividing by each other, so I will divide the bases 8 over 2 and I will take power once, and further I will simplify this. 2 times 4 is 8 and this gives me 4 power 2. Number 5. If I have a power m whole power n, so we have to remember that powers always multiply with each other, so I will write a power mn. For example, if I say 2 power 3 whole power 2, so I will write it like 2 power 3 times 2 is 6. Number 6 rule, if if I have a power 0, the answer is 1. Any number, if its power is 0, for example, if I write 27 power 0, the answer would be 1 straight away. No need to calculate anything. Number 7, if I write a power negative 1, so the negative index can be changed into positive by taking the reciprocal. So 1 over a power 1, which is 1 over a. For example, if I write 2 power negative 3, so this can be written as 1 over 2 power positive 3, which is further can be written as 2 power 3 is 8. So 1 over 8. Let's solve some question. Simplify. 4a power 3 b whole power 3. So everything inside the bracket has the power 3. So I will write it like this. 4 power 3 times a power already 3. The whole power is 3. So 3 into 3 is 9 into b power 3. So 4 power 3 is 64. A power 9, b power 3 would be our answer. B. If I have a question to simplify minus 2x y square whole square, as I said before, everything inside the bracket has now the power 2. So negative power 2 means negative is going to multiply 2 times. Negative into negative makes positive. So no need to write positive, and I will start it from writing 2 power 2 times x power 2 times y is already power 2, so powers always multiply with each other, so y power 2 into 2 is 4. So 2 power 2 is 4, x power 2, y power 4 would be my answer. Now part C. If I have given 2a squared b power 3 whole power 4 times another bracket a power 3, b is 1 power 1 and whole power 3. So let me write 2 power 4 times a power, already a has a power 2 and the whole power is 4, so 2 into 4 is 8 times b power 3 times 4 is 12 times, now a power 3 times 3 is 9 into times b power 3. So 2 power 4 is 16. Now a power 8 times a power 9. Bases are same, they are multiplying, so power must be added. So a power 8 plus 9 is 17. B power 12 and b power 3. Bases are same, they are multiplying, power must be added. So b power 12 plus 3 is 15. So this would be my final answer for this. Now let's try some fractional indices and the radical form. Suppose if I am given a power m over n, this is my fraction in the index. So I can convert this into the radical form. So you have to remember that the numerator in the fraction becomes a power of a and the denominator becomes the root of the radical form. So for example, if I gave you to write 2 power 3 over 4 in the radical form, so follow the rule like numerator of the fraction will become the power of 2. You write 2 power 3 and the denominator of the fraction become the root and write 4 here. So let's do some more example on it. Suppose if I write 4 power 1 over 2, the radical form is 4 power 1 and the root is 2. Whenever the root is 2, we don't need to write it. It is normally known as square root, and the power 1 is never written. It is understood that the power is 1, so this is actually square root of 4, which is further, you can write plus minus 2. Let us do one more example. Suppose if I write 27 power minus 1 over 3. So the radical form would be, before converting it into radical form, let me convert the negative power into positive. So I will write 1 over 27 power 1 over 3. So now I can write 27 power 1 and the root is 3, means a cube root. So cube root of 27 is 3. We have to select a number when we multiply that number 3 times because we have a cube root, so it should give us 27, and that is 3. 3 into 3 into 3 gives us 27. Let's do one more. If I write 100 power 1.5, so 1.5, convert it into a fraction. So decimal give you 1 and 5 give you 1, 0. So this is 15 over 10, decimal has gone. So 5 times 3 is 15, 5 times 2 is 10. So you get 3 by 2 from 1 over 5. So I can write 100 power 3 over 2. Now we can convert it into radical form. So 100 power 3 and the denominator goes to the root. It means that the square root of 100 power 3, which is 1000. Okay, one more learning in this. If I say 2 power x is equal to 32 and I say find the value of x, so you have to convert 32 into the index form and the base must be 2. So I can write 2 power 5. 2 power 5 means 2 multiply 5 times, which makes 32. So I have converted 32 into the index form, 2 power 5. So the bases on either side of is equal to sign are same. So my power becomes my answer. I can say x is equal to 5. If I have 5 power minus x is equal to 1, so what to do with 1? I can write that 5 power minus x is equal to 5 power 0. As we know that any number whose power is 0, the answer is 1. So I made the bases same on either side of the is equal to sign. So my power is my answer now. I can write minus x is equal to 0. So 0 has neither sign nor positive nor negative, so my answer would be x is equal to 0.